Makita na lang.
Makita ka, Carl.
Good afternoon, everyone, sir, classmates. So today we will report about sensors and transducers. And together with me, my group mates, Carl Angelo Villayo, Jeffrey Albay, and yours truly, Neil Caballero. Next slide, please. So here are the list of topics that we are going to discuss for today's reporting. So later on, ato na silang mga ma-cover up ng mga different topics. So next slide, please. So first, what are sensors? So sensors are termed as the devices that generate an electrical signal or optical output signal corresponding to the variations in the level of inputs. So it is usually a module or chip that observes the changes happening in the physical world and sends the feedback to the microcontroller or microprocessor. So shown here is a simple block diagram of a sensor. So as makita, these analog values from the outside world is mo ni siya ang gina-sense sa atong sensor. And the sensor itself ay katong chip. And fun fact, most of the sensors can't work independently. So sufficient input voltage should be applied and also grounding para mo-work siya properly. So as makita diya, nasa taas power supply. And sa ubos is ang ground. And ang output din niya is voltage or current output niya. Depende po if analog or digital siya na sensor. So next. So classification of sensors and its stimuli. So the scheme of classifying sensors can range from very simple to very complex. The stimulus that's being sensed is an important factor in this classification. So listed here are the different stimuli used in different sensors for different applications. So first is ang acoustic, which includes wave, spectrum, and wave velocity. Next is electric, and it may be current, electric current, charge, potential, electric field, permittivity, and conductivity. Next is ang magnetic, which is including ang magnetic field, magnetic flux, and permeability. Next pod is thermal, which is katong temperature, specific heat, and thermal conductivity. Next is mechanical, which includes position, acceleration, force, pressure, stress, strain, mass, density, momentum, torque, shape, orientation, roughness, stiffness, compliance, crystalline, and structural. So medyo taas-taas din yung mechanical na part. And lastly is ang optical, which includes wave velocity, refractive index, reflectivity, absorption, and emissivity.
So on to the next part of our presentation. So now we will talk about the classification of sensors. So yun ako daan na nakoy nami mga definitions sa mga sensors na present today, pero wala na mag-include the slide due to the huge amount of text with up. So like, decide lang nga, amo lang i-upload siguro ang notes if gusto niyo. So yeah, wala to. Okay, so first, we split the classification of sensors into 10 groups. So the first group is displacement, position, and proximity sensors. So, okay na. So at that chart are images of the sensors or what they will look like. So first is the potentiometer. So a potentiometer is a 3-terminal resistor with a sliding contact where the position varies across a uniform resistance so that it could control output voltage. So this particular sensor is used in gaming joysticks to measure positions or to control audio equipment. So muna yung potentiometer then. Then next is the capacitive elements. So these are non-contact devices that can detect the presence or absence of any object regardless of material. So it utilizes electrical property of capacitance and it's changed based on the electric field on the active phase of the sensor. So muning example, so it is used in digital audio players, mobile phones, and tablet computers and more. So next we have the strain gauge element. So here's an image of its internal structure, or what would the parts look like. So this particular sensor, the resistance of the sensor changes when force is applied. So it could give varying electrical output. So this is used to measure pressure, force, weight, tension, and many more. So okay, next we have inductive proximity sensors. So this is the sensor, or what it will look like. So this sensor detects magnetic loss due to eddy currents that are generated on a conductive surface by an external magnetic field. So this particular sensor is commonly used on forklifts when they carry weights. So next we have eddy current proximity sensors. So this is the the workings of the sensor when magnetic field is, or what it will look like when the magnetic field is being measured. So this sensor detects the presence of a target by sensing fluctuations in the magnetic field generated by a reference coil. So this is used in highly dynamic acquisition of vibrations of turbines and regulation of the gluing process in the production of corrugated cardboard. Okay, so there are 6 more sensors in this category. So the sixth one is the differential transformer, also known as linear differential transformer. So muna siya ang differential transformer. So this electromechanical sensor is used to convert mechanical motion into a variable electrical current, voltage, or electrical signal. So this is commonly used in automation. So next we have optical encoders. So this circle-shaped sensor is the optical encoder. So this is a motion sensing device that uses light. As you can see, there's an LED. So this is where the light is projected. So the light shown through a coded disc to track the movement of a shaft. So it provides feedback based on the interruption of light. So this particular sensor is used on machine tools, CMMs, and robotics. Next, we have Hall effect sensors. So Hall effect sensor is this image right here, where it has 3 long legs. So this sensor detects the presence and magnitude of a magnetic field using the Hall effect. So the output voltage of the sensor is directly proportional to the strength of the field. So this is used to time the speed of wheels and shafts. Next, we have I'm not sure how to pronounce this, but it is pronounced pneumatic sensors. So this particular sensor, or yes, this sensor, this right here, generates electrical signal in proportion to the pressure they measure. So when force is applied to the sensor, electrical resistance varies from the pressure. So commonly used in heavy machinery like drills. Next, we have proximity switches. So here's an image of it. So it is used to determine how close an object is. So it is determined by certain means such as magnetic, electric, or optical. And lastly, for this category, we have rotary encoders. So this particular sensor has a sort of a shaft. So as you can see. So this is an electromechanical device that converts the angular position of a shaft, which you can see here, to analog or digital output signals. So, convert niya kung unsay angle aning particular shaft into signals. So, this is particularly used in packaging, printing, textiles, and many more. So, for the second category out of the 10 categories, now we have temperature sensors. So, based from its name, so we know that all these sensors have the same purpose to measure temperature, but the main difference between these 5 are the means or the methods on how they measure temperature. So first we have the thermistor, just this. So okay, malinaw po. Okay, so a thermistor, which is also called the resistance thermometer. So this sensor's resistance is dependent on temperature. So next is we have the thermocouple. So a thermocouple consists of two different types of metals joined together at one end. So when the junction of the two metals is heated or cooled, a voltage is created that can be correlated back to the temperature. So next we have bimetallic strips. So this is an example of a bimetallic strip. So as you can see from the image, it is a type of sensor where two strips of dissimilar metals are mechanically joined together, either by rivets or being fused together along their length to form a structure that responds to changes of temperature by bending in a preferred direction. So this is commonly used in mechanical clocks and thermometers. Next, we have resistance temperature detectors. So this muna ang resistance temperature detector. So it is an electronic device used to determine the temperature by measuring the resistance of an electrical wire. So as the temperature increases on the sensor, the resistance also increases. Next, we have the thermostat. So this thing, I think it's a familiar device. So this particular sensor detects temperature changes for the purpose of maintaining the temperature. So it is used as a control unit for HVAC systems such as boilers, furnaces, electric heaters, and many more. Okay, so onto the next category, we have light sensors. So these group of sensors are used to measure or send electrical signals by measuring light. So first, we have the photodiode. So a photodiode is a semiconductor PN junction device that converts light into an electrical current. The current is generated when photons are absorbed in the photodiode, so particularly used in safety electronics such as fire and smoke detectors. Next, we have the phototransistor. So looks similar to the photodiode. So this is an electronic switching and current amplification component which relies on exposure to light to occur. So it is commonly used to detect light pulses and convert them into digital electrical signals. And for main applications, commonly used in punch card readers, security systems, and encoders. And next, we have the light-dependent resistors. So based on the name of the sensor, so we know that this particular sensor is used to detect light levels by decreasing the resistance when light intensity increases. So commonly used in alarm clocks and such. So onto the next category. So we have sensors for velocity and motion. So first we have pyroelectric sensor. So this is what it looks like. So a pyroelectric sensor is designed specifically for human detection. So it is made of a crystalline material that generates a surface electric charge when exposed to heat in the form of infrared radiation. Next, we have tacho generator. So this thing. So it is an electromechanical device which outputs a voltage proportional to their shaft speed. So it is used to power tachometers and to measure the speed of motors, engines, and other rotational devices. Next, we have the incremental encoder. So an incremental encoder is an encoder device that converts angular motion or position of a shaft into an analog or digital code. So kanin siya commonly used in positioning and motor speed feedback applications, which includes servo, industrial, or heavy-duty applications. Now to the next category, sensors for fluid pressure. So for this category, first we have the diaphragm pressure gauge. So this is the diaphragm pressure gauge. So it is a device that utilizes the deflection of a flexible thin membrane called the diaphragm to measure the pressure of the fluid in a system. So commonly used in measuring atmospheric pressure or monitoring pressure in a gas canister. So makita siguro ni nato sa mga tanks na ga-fill of gas or ga-store gas. So next we have tactile sensor. So I'm pretty sure this tactile sensor right here. Yep. So this particular sensor is sensitive to touch, force, or pressure and are made using light, electricity, or magnetism. The stimulus to response pathway seen in electric touch sensor operation mimics the human body process that involves our skin, signal transmission by the nervous system, and the brain. So commonly used in robotics, computer hardware, security systems, and more. So next we have piezoelectric sensors. So piezoelectric sensors is a sensor where the electric charge is generated when force is applied. So it is commonly used in cell phones and diesel injectors and acoustic guitar pickups. So now next we have capsules, bellows, and pressure tubes. So these are three different devices, so just not be confused. So first we have capsules. So no, this is the piezoelectric sensor. I have not attached an image for capsule, but capsules consist of two diaphragms joined and sealed around their circumference. So these types of sensors are designed to measure low pressures and vacuum. So next we have bellows. So I think, yeah, this is the bellows image. So bellows pressure sensor is made of a sealed chamber that has multiple ridges like the pleats of an accordion that are compressed slightly. So when pressure is applied to the sensor, it will try to expand and open the pleats. So magkuhan din siya mag-create siya output para ma-measure ang amount of pressure na isulod. So then lastly we have pressure tubes. So this is also called as tube pressure gauges. So it uses the principle of a flattened tube, which tends to straighten or regain its circular form in a cross section and pressurize. So maning magkuhan example. Okay. Now onto the sixth category of sensors. Now we have a group where it measures liquid flow and level in particular. So first we have the turbine meter. So this is an image of the turbine meter. So it uses the mechanical energy of the liquid to rotate a rotor within the flow stream. The rotational speed is directly proportional to the velocity of the fluid traveling through the meter. So these meters are used to reliably measure liquids, gases, and vapors. Next, we have two different types of devices called the orifice plate and the venturi tube. So this is an image of the orifice plate. So these are used as restriction devices to regulate fluid flow in systems, while venturi tubes are used to measure the speed of a fluid by measuring the pressure changes from one point to another along the vent tube. So as you can see in the design, gamay nga pathway para mas paspas ang flow sa fluid and para pod nga mas dali ma-measure ang pressure. Okay, so moving on, now we have IR sensor or infrared sensors. So here we have the infrared transmitter and receiver pair. So they're two different devices, but they work together. So this particular pair of devices commonly used in remote controlling applications. So mga TV remotes and such, or control gear mga nanang devices. So the IR transmitter emits infrared light modulated at a particular frequency, while the IR receiver will receive this modulated signal and then demodulate it. So now next we have sensors for measuring force. So I mentioned earlier ang strain gauge. So i-review na ito. So strain gauge is particularly used in measuring different types of measures, so or units, which is the pressure, force, weight, and tension. So next we have the load cell. So a load cell is a sensor that detects force and converts it into an electrical signal. So this particular sensor is commonly used in weighing, scales, and medical equipment. Okay, next, now we have touch sensors. So this from its name, so these are sensors that are sensitive to touch. So first we have the resistive touch sensor. So this is the resistive touch sensor. So this particular sensor senses the pressure on the surface. It accommodates non-conducting materials like stylus and glove wrap fingers. So commonly used in musical instruments, keypads, and touchpads. Meanwhile, the capacitive touch sensor senses touch inputs by varying capacitance values. So widely used due to durability, robustness, product design, and cost. So, may siyang particular sensor nga ginagamit sa mga mobile phones due to its flexibility and durability. Kay ang capacitive sensors ga allow og kanang different types of input like kanang mag-pinch ka sa imong screen or mag-drag ka o sa imong finger and such. While ang resistive sensor, dili niya ma-read ang input. So, among difference. Okay, now last we have UV sensors for the. So this particular group of sensors work with the UV light spectrum. So okay, so first we have the ultraviolet light detector, which is this particular thing. So I mean, meron siya, I think dili mo ako nakuha ang image, but meron siya may flashlight siya, but nonetheless, UV light detector is or are groups of non-destructive chromatography detectors that measure the amount of ultraviolet or visible light that is absorbed by components of a mixture being eluted off the chromatography column. So, commonly used in pharmaceutical industries, biotech, and oil and gas industries. Next, we have photostability sensors. So, I think mo yung image na nakita sa Google. So this is used to measure fluorescence and intensity over time. So commonly used in evaluating the overall photosensitivity of materials such as drugs. So next we have UV phototubes. So this particular sensor is a gas field or a vacuum tube that is sensitive to light. It operates according to the photoelectric effect. So it is used in the reading of optical soundtracks for projected films and light sensing applications. And lastly, we have germicidal UV detectors. So this particular detector is used to measure irradiance of dominant low pressure germicidal sources. So particularly kanada tong mga germicidal devices na kina-use to purify the air of mga microbes. So next we have the basic requirements of a sensor or transducer. So first we have the range. So obviously the range, it indicates the limits of the input in which it can vary. Next we have the accuracy, which is the degree of exactness between actual measurement and true value. Next we have sensitivity, which is the relationship between input physical signal and output electrical signal. It is the ratio of change in output of the sensor to unit change in input value that causes change in the output. Next, we have stability. So this is the ability of the sensor to produce the same output or constant input over a period of time. Next, we have repeatability, which is the ability of the sensor to produce the same output for different applications with same input value. Next, we have the response time, which is the speed of change in output on a stepwise change in input. Now we have linearity. So this is an indication of deviation of curve of actual measurement from the curve of ideal measurement of a sensor. So like then now we have ruggedness, which is the measure of durability when the sensor is used in or under extreme operating conditions. And finally, we have hysteresis, which is defined as the maximum difference in output at any measurable value within the sensor specified range when approaching the point first with increasing and then with decreasing the input parameter. So basically, it is a characteristic that a transducer has in being unable to repeat its functionality faithfully when used in the opposite direction of the operation. So, so now we discuss commonly used sensors and transducers today. So first, we have for sensing light. The input devices or sensors are photodiode, phototransistor, light-dependent resistor, and solar cells. So the output devices or actuators are LEDs, displays, lamps, and fiber optics. For sensing temperature, we have sensors such as thermistor, thermocouple, resistance temperature detectors, and thermostat, while the actuators are heaters. For sensing position, we have the input devices, which are potentiometer, proximity sensor, differential transformer, while the output devices are motor and panel meter. For sensing pressure, the sensors are strain gauge and load cell, while the actuators are lifts and jacks and electromagnetic vibrations. For sensing sound, the input devices are microphones and output devices are loudspeakers and buzzers. For sensing speed, the sensors used are tacho generator and Doppler effect sensors. So the actuators are motors and brakes. So now we discuss about analog sensors. So analog sensors produces continuously varying output signals over a range of values. The output signal is voltage and it is proportional to the measurement. The response time and accuracy of circuits using analog sensors is low and less, hence why analog to digital converters are used. Analog sensors generally require an external power supply and an amplification of some form to produce appropriate output signals. An example of analog sensor would be the thermocouple, which is used in temperature sensors. Now we talk about digital sensors. So these type of sensors produces discrete digital signals. So the output of these sensors only have two states, namely on and off. So the accuracy of a digital sensor is high when compared to analog sensors. So an example of the sensor would be the push button switch. So now we have Geoffrey to present or talk about transducers.
So moving on to the transducers. So what are transducers? A device that converts one form of energy into another by the principle of transduction. So kaning principle of transduction basically mo siya nga conserve of energy. So usually a signal in one form of energy is converted to a signal in another form by a transducer. Also, it converts a non-electrical quantity into an electrical quantity. So below is the diagram of a transducer. So there are three basic elements in transducer, namely sensor, signal conditioning unit, and data representation. So sa sensor, any changes in the input quantity will be detected by a sensor and reflected as changes in output quantity. So makita to diri sensor. The next then kay the signal conditioning unit is used to convert the non-electrical output of the sensor to an electrical quantity. So then lastly, kanang data representation, it is used to present the measured output to the observer. Next slide. So it is easy to classify transducer as input transducer or output transducer if they are treated as simple signal converters. So first, input transducer. It measures non-electrical quantities and convert them into electrical quantities. So example ani is microphone. So kibali kung produce tag sound dinadetect sa microphone kanya gina-convert tong sound into electrical signal. So next is ang output transducer. Kani siya ang opposite sa input transducers. Their input signals are electrical and their output signals are non-electrical. So example ani kay ang speaker. So from the electrical signal to the speaker mag-produce ang sound. So ang output niya is non-electrical. So next slide. So transducers are based on the following three ways. So first is the physical effect. So physical effect is engaged to convert the physical quantity to electrical quantity. An example is the change in resistance of a copper element in proportion to the change in temperature. So the following physical effects are generally used. So there are five components of variation in resistance, variation in inductance, variation in capacitance, Hall effect, and piezoelectric. So ang image sa right, ang order na niya is from top to bottom sa description. So next slide. So the second is the physical quantity. It is based on the physical quantity converted sa katong physical effect. So example ani is the end use of the transducer after the conversion. So the following physical quantity are generally used. So there are 7 types: temperature transducer, pressure transducer, displacement transducer, level transducer, flow, force, and acceleration transducer. So same gyapon sa last slide nga ang order sa image is from top to bottom. So next slide. So for the last classification is the source of energy. Under this category, there are usually two types of transducer, and these are active and passive. So first, we will discuss about active transducer. So the energy from the input is used as a control signal in the process of transferring energy from power supply to proportional output. So ubos ani is ang block diagram sa active transducer. So for instance, strain gauge is an active transducer in which ang strain mo ng measured medium is converted into resistance pinaagi sa active transducer. But since the energy from the strained element is very small, the energy is for the output is provided by an external power supply. So kana sa taas sa active transducer. So next slide. So next is the passive transducer. The energy from the input is directly converted into the output. So ubos ani is mo na siyang block diagram niya. So for example, a thermocouple is a passive transducer where the heat energy, ang kanang measured medium, is absorbed from input, then converted into electrical signals. Ano siya? Stage. So next slide. So moving on, characteristics of transducers. Transducers can be further classified into two types, static and dynamic. So first, for the static characteristics, is a set of performance criteria that are established through static calibration. So example is description of the quality of measurement by essentially maintaining the measured quantities as constant values of varying very slowly. So the following is a list of some of the important static characteristics. There are 11. So sensitivity, linearity, resolution, precision, span and range, threshold, drift, stability, responsiveness, repeatability, and input impedance and output impedance. So next slide. So next is the dynamic characteristics. It relates to its performance when the measured quantity is a function of time. So gavary siya rapidly with respect of time. It relates also to dynamic inputs, which means that they are dependent on its own parameters, as well as the nature of the input signal. So the following are some dynamic characteristics that may be considered. So kani upat, dynamic error, fidelity, speed of response, and bandwidth. So overall, both static and dynamic characteristics of a transducer determine its performance and indicate how effectively it can accept desired input signals and reject unwanted inputs. So next slide. So moving on to different types of transducers. So there are two types of transducer, mechanical and electrical. So for mechanical transducers, it responds to changes in a physical quantity with a mechanical output. So output signals are mechanical. So the output mechanical quantity can be anything like displacement, force, torque, pressure, and strain. Next slide. So under a mechanical transducer, there are 6 categories. So the first category is the temperature. So bimetallic strips, so na-discuss namin siya before ni Car, so hindi na ko siya i-mention. And kung day ka na, ang order po sa image siya right from top to bottom. So next is the fluid expansion. When a liquid is heated in a container, it flows through the container to the liquid, which means that the container expands first due to which the level of the liquid falls. So next category is the pressure. Under pressure, there are 4 types. So first, the ring balance manometer. It consists of a tube usually made of polythene or other suitable light and transparent material. Next is the metallic diaphragms. Circular and thinly cut plates that experience elastic distortion when exposed to eggshell loading or pressure. So next is the capsules and bellows. So kanina na-mention na po siguro ni siya ni Carl, so natin na siya i-discuss. So lastly is the membranes. It's essentially an electrical switch that used for turning on and off the circuit. So next slide. So next category is the force. Under force, there are 3 types. So first, the spring balance. It is commonly used to measure the force exerted on an object. And then next is the hydraulic load cell. It is used as a conventional piston and cylinder device that conveys a change in pressure. It is a force balance method acting when the internal filling fluid pressure changes. Next is the column load cell. It is designed to measure loads in compression. The next category is the torque. Under torque, there are four types, and the first type is the dynamometer. So dynamometer is a device for measuring force. Oh, kana. So next is the gyroscope. So kanang gyroscope is a device containing a rapidly spinning wheel or circulating beam of light that is used to detect the deviation of an object from its desired orientation. So next is the spiral springs. It is widely used in mechanisms such as mechanical watch movements and clocks where the spiral spring is used for timekeeping. The next is the torsion bar. Resists twisting and has a strong tendency to return to its original position when twisted. The next slide. Then next category is the flow rate. So under flow rate, there are two types. First is the flow obstruction element, a device inserted into the flowing fluid that produces a physical property that can be accurately related to flow. So next is the pitot tube. So a pitot tube is mainly used for making temporary measurements of flow, although it is also used in some instances for permanent flow monitoring. And lastly, liquid level. So isa ra ang nakita sa liquid level, which is the manometer. The pressure to be measured is applied to one side of the tube, producing a movement of liquid. So next. So next slide is to be discussed by Neil.
So moving on, for the other type of transducer is the electrical transducer. So it is a transducer which respond to changes in physical quantities with electrical outputs. So it gives electrical energy as an output, as what it is stated there. So these transducers convert one form of energy into an electrical signal. And here, one form of energy may be heat, light, or sound, and the electrical signal can be frequency, current, or voltage. So next slide, please. So first is the passive electrical transducers. There are two types of electrical transducers, the passive and the active. So first we'll discuss about the passive electrical transducers. So first is resistive transducers. So these transducers are most frequently used for calculating different physical quantities like pressure, vibration, temperature, force, and displacement. So the resistive transducer converts the physical quantities into a variable resistance, which is easily measured by the meters. So the process of variation in resistance is widely used in industrial applications. So these examples are few of the many types of transducers. So first is resistance thermometer. So resistance thermometers are depends on the change of resistivity of any material when the temperature changes, and this change in the resistivity causes a change of resistance. So this is a non-contact na transducer. So if na siya ma-detect na change in resistance, muna dito siya ang mahimo, like muna to na dito mag-base ang output dayon. So these are equipped with platinum sensor elements which change their electrical resistance as a function of temperature. So kanang nasa topmost na picture mo na siyang example of resistance thermometers. So next is resistive displacement transducers. So it is an electromechanical device used to convert mechanical motion or vibrations, specifically rectilinear motion, into a variable electrical current, voltage, or electrical system signals, and also the reverse. So sa second, ang order aning pictures is from top to bottom kay muna na siya ABCD ABC. So kanang next picture mo na siyang example of a resistive displacement transducer. So basically, ang resistive transducers kay same lang sila ang concept na mag-base lang sa change in resistance mo na din siya ang dito na din mag-base ang output din sa transducer. So last for the resistive transducer is a resistive strain transducer. So it operates by converting physical quantities into mechanical stress in a component called a sensing element, and then electrically converting that stress with a strain gauge. So strain gauge, as I mentioned sa slides before, Ani. So yes, muna ka siya. Next is the capacitive transducers. So capacitive transducers are used for measuring the displacement pressure, and other physical quantities. So much like the resistive transducers lang. So it is a passive transducer. That means it requires external power for operation. The capacitive transducer works on the principle of variable capacitances. And the capacitance of the capacitive transducer changes because of many reasons, like overlapping of plates, change in distance between the plates, and dielectric constant. So same sa kuan non-contact na transducer siya. So first example would be the capacitive moisture transducers. So it works by measuring the changes in capacitance caused by the changes in the dielectric. So kanang picture nga na ay background na black, the fourth picture, muna siya example sa moisture transducer. So next is the capacitive displacement transducer. Also, non-contact devices capable of high-resolution measurement of the position and change of position of any conductive target. So kaning na more blue sa bottom, kana siya. Kana siyang example. And lastly is the capacitive thickness transducer. So same concept Japon sa displacement transducer, but mas refined siya kay mas smaller man siya nga gagmay nga units ang ginagamit. So next slide please. Third is the inductive transducers. So inductive transducers work on the principle of inductance change due to any appreciable change in the quantity to be measured. So example, sa kanang LVDT, which is a kind of inductive transducers. It measures displacement in terms of voltage difference between two secondary voltages. So example, number 1, inductive displacement transducer. So matokong giingon, baga lang, na utilizes changes in output voltage when an armature moves in a coil. So this example would be an indirect displacement or position measurement. So kaning first na picture nga mura siya kanang cord sa microphone, ba? Magigana. Then next is inductive thickness transducers. Well, sa kaninga part wala kay may nakita nga picture, but same na siya gapon ng concept sa displacement, but again mas smaller units. And lastly is the eddy current inductive transducers, which I believe na discussed earlier, but that type lang kay sensor, in this case transducer. So ang eddy current uses the effect of eddy circular currents to sense the proximity of non-magnetic but conductive materials. So a typical eddy current transducer contains two coils, an active one and a balanced coil. So next please. So now we move on to the active electrical transducers. So the first type is the photoelectric transducers. So photoelectric transducers converts the light energy into electrical energy. It is made of semiconductor material, and it uses a photosensitive element which ejects the electrons when the beam of light absorbs through it. So first example sa photoelectric transducer is photoconductive transducers. So it works on the principle of photoconductive effect. So when the light strikes a semiconductor material, there is a decrease in the resistance of the material, thereby producing an increase in the current. So generalized lang ang mga pictures ani, so kanang 3 ka transducers nga nagtapad mo na siya ang mga different types of photoelectric transducers. So the second type is the photoemissive transducers. So the principle of working of photoemissive transducer is based on the emission of electrons when the transducer is exposed to sunlight. So basically katong from the word emissive, so mag-emit siya og electrons when exposed to light. So next is the piezoelectric transducers. So these transducers are a type of electroacoustic transducer that converts the electrical charges produced by some forms of solid materials into energy. So the word piezoelectric literally means electricity caused by pressure. So example is kanang piezoelectric strain transducers and piezoelectric acceleration transducers. So wala kay makakita Japon og like picture jud sa transducer, but mo ni siya ang one type na mo nakita, which is like makita sa mga cell phones, TVs, and etc. So next. Next type of an active electrical transducer is the magnetostrictive transducer. So same sa kalaban sa DC. Okay. So magnetostrictive transducers makes use of a type of magnetic material in which an applied oscillating magnetic field squeezes the atoms of the material together, creating a periodic change in the length of the material and thus producing a high frequency mechanical vibration. So like mag-rely siya mainly on the katong magnetic field, like same sa katong nastorya kanina sa sensors nga ang stimuli niya is basta based on magnetics. So example would be magnetostrictive acceleration transducers and magnetostrictive force transducers. So kanang first two pictures above. So next is the electromechanical transducers. So these are devices for converting mechanical motion into variations of an electric current or voltage, and vice versa. So electromechanical transducers are used primarily as actuating mechanisms in automatic control systems and as sensors of mechanical motion in automation and measurement technology. So like as na nasturya dito nga common na siya in mga mechanical nga applications. Mechanical, electromechanical. So tachometers, example. So tachometers is an instrument that measures the working speed of an engine, which is typically in revolutions per minute. So familiar ang RPM na kanang sa mga sakyanan, motor, sa RPMs, and commonly used in boats, cars, motor. Yes. So kanang third picture kanang may zero, and usually ang display niya is in analog or digital na display. Next is the electrodynamic pressure transducers. So murag dili ni siya maujud ang exact nga picture but similar lang siya ani. Kay kani siya sa same ni siya sa katong isa ka pressure na transducer. So yes. So next slide please. So lastly, for the active electrical transducers is the ionization transducers. So ionizing transductive elements transform the change of measurable value into change of ionization current that runs, for example, through the liquid located between two electrodes. So an example of this is kay kanang pH meter. So kanang pang measure sa pH level sa usa ka liquid. Okay, yes, kay liquid man. So an example would be an ionization vacuum gauge. So it is a device which is used for the measurement of pressure in vacuum systems or in the very low pressure region. So more siya nga example ang may picture so kanang makita sa right. And next is ionization displacement transducer. And also, to add lang, ang ionization transducers kay makita pod in some smoke detector systems which are powered by kanang mga ionization transducers. So that's it for the active electrical transducers in both the passive and the active classes. So that's it for our report. So kani siya ang mga references na mong ginagamit sa pagbuhat sa content sa among report. That's it. Thank you for listening and God bless. Char.
All right. How about a round of applause to our reporters? Thank you guys no sa inyong report regarding sensors and transducers. Okay. So it's 2:30. Remind lang ko na ma-open ang quiz on 2:45. No, 5 minutes lang to. 5 minutes, 5 questions, very short quiz. So ma-open siya in a while. In the meantime, questions ata, no? Ato sang i-grill atong mga reporters. Do you have any questions? Ang inyong i-prepare for them? Something dili clear sa inyo or wala? Or nalibog mo nga part? Wala, send notes daw.
Mag-send na may notes unya sa GC, guys.
Wala niya pa daw.
Karon.
Sige, ako na quick question. No? Anyone lang sa inyo ang three mag-answer. So you've tackled light sensors, particularly photodiodes and phototransistors. Now, for sure, sure ko na ang basic gina ng idea, no, let's just say wala jud ko'y hanaw-ana nga mga devices. Okay? And then, inyong gipresent kanina. And based akong pag-understand, tungkol kay light sensor siya, once light is detected, the device works. Okay? So if ang ako lang background is electronics 1, so I'm picturing a diode, but this time, light ang mag-bias sa iyaha, no? So, magyan naman ng photodiode. Ang phototransistor is the same gapon sa regular transistor, perhaps. But again, this time, light tas ang magkuhan sa iyaha, no? Mag forward bias gapon. So, ang question is, what's the advantage of one over the other? No, kana lang. No? Maski asa lang sa inyong tulo. So, unsa advantage sa pag-use sa photodiode? Na by advantage ang photodiode over the phototransistor, or na by advantage ang phototransistor over the photodiode? Or basically what I'm asking is unsa main difference lang duha, no, in terms of application kay let's just say nga ang akong assumption na ako na no. Let's just say ang akong assumption is pareha man gining duha, pareha man yung photodiode phototransistor. But maybe na amoy idea, reporters, unsay difference sa duha?
Ako lang matubag, sir, kay ako may nag-replicate sa sensors. So, ako particularly, dili ko sure if napagit advantage kay di mo ko sure sa inner workings based on research. But what I know, sir, is that ang photodiode kay commonly used gid siya on safety electronics, so mga fire and smoke detectors. So based from that principle, I think gina-use ang photodiode as a way to power certain systems through observing light. While ang phototransistor kay commonly used in punch card readers and security systems and encoders. So kani sila kay ga-detect gapon sila of light, but I think ilang purpose is to uh, to send signals na kanang digital to. So I think kana lang, sir. I think both do the same thing, but main advantage siguro gid kay ma-use ang kaning nga device. I mean, wala advantage, di na makakuan with tarong, but more like lahi ang ginagamitan sa each device. So kana lang siguro.
Okay, thank you, Carl. So basically, basta kay kung whatever application siya mag-fit, mo itong gamitan, no? So just like mag-ingon, if for detection or sensor mag isang duha, but for detection, just like ito, fire detection fire detection ba to? So we'll use a photodiode, but for other applications na more sophisticated, no, or for more complex, mas well suited ang phototransistor. Okay. So thank you Carl. So sakto sa to yung ni Carl class na yes, dili man pud not necessarily compare gid ang duha, no? It might not be accurate to say nga one is advantageous over the other. It's just that laylay like applications, no? The same would happen sa regular nga diode o regular nga transistor. So depende sa application, dili man tanan nga time switching is transistor gatong gamitan. What if diode lang ang kinahanglan? So ayan nagyapon sa photodiode ng phototransistor. Okay, so thank you, Carl. What else? Kamo, sino mo yung questions, guys? Mag-questions kay na plus points. Kanang question nga related sa report, ha? Alam ko yung mga na-think ganina, but wala na ako na-list down. Motong akong pwede may madumduman kay pinaka-common man good light sensor. Ako sa inumdumon so itong mga nakam up na akong questions kanina. Kani so man si Carlo Tubag no, either ni Joplin na lang or ni Neil. Pero unsa gyud pinaka-simple nga timailhan or difference between active ug passive nga transducer or sensor?
Hello sir. So based lang sa physics mo sa una sir kay 'di ba ang active na mga di mo sa una yata sa physics nga active nga type of components kay katong mga dili po components sa tawag na electrical quantities kay katong capacitance, resistance, and inductance. So
Passive ata na.
bali. Oh, sakto sir kana, bali.
Mm.
So based lang adto sir, murag mulang akong ma-think nga distinction lang gid mga ngano siya matawag nga passive na electrical transducer based lang sa name, based lang sa pag-classify sa ila as electrical quantities.
So kung dili resistance or capacitance or inductance,
Diretso na siya sa peak.
active siya.
Yes sir. I guess. Yes.
Sige. Kamu klase may questions or basig maulaw mo gasa, basig isabot na mo daan nilang tulungan, di mo mag-ask ha. Ang next question, whatever man nga question ma-come up, is si Joffrey na magtubag kay siya na naman wala nakakuan. Kung wala ka man sa inyong mga question, class, mga gwapo naman. Na-question si Romo. So, kisa man mag-answer ani. Joffrey? I-expound daw yung question ni Romo sa episode ani. Tanan passive ang non-contact or katong passive lang? Yung pasabot kay non-contact ba ang mga passive? Or sabi mong question? Non-contact ba? No, meaning dili touch, right?
So kung din na siya kanang tanan passive kay non-contact na siya.
So ang capacitive,
mag-base na siya sa change in capacitance o katong
di ba,
din ganyan.
tanan passive ang non-contact or tanan ba non-contact kay passive? Di ba ang capacitive kay contact man gyapon na nga type of sensor kay kinahanglan man ka mag-touch.
Yes sir.
Okay, so I think so maapas nga question, no? So before we end, ito gani. kanang Natoy part ganina sa isa sa mga slides, I think ang job dito sa pag-introduction sa transducers nga dito mo sulod ang akong topic next meeting, signal conditioning, no, kato. So it's sort of like ang next na akong topic is interfacing man. So ang question now is I hope na-ask ko ninyo ganina while listening, no. So sa kadaghan nga sensors o transducers o even actuators, no. And daghan sila mga call this parameters or physical quantities nga gina-measure. How is it that the microcontroller, no, or any microprocessor could read the sensors? Bantay ta na ang example Arduino, no, especially katong some of you nga naka-experience na gamit og Arduino. Ang Arduino, basically maski unsa nga sensor imo isaksak sa iyaha, pwede gid siya, no. I mean magamit gid siya. So how is kanang rhetorical lang ni siya. No need to answer this one, but just I hope na-ask niyo ni sa inyong selves earlier or na-ask niyo ni before, but I've asked this one po sa una, katong first ko na-encounter ani. Na how is it na ang mga microprocessors or microcontrollers are capable of reading the outputs of sensors. Na daghan mga klase sensors or lahi-lahi sila mga inner workings, lahi sila physical construction. So how is it that pwede ta mo connect o different types of sensors to microcontrollers, or particularly the Arduino or even Raspberry Pi? So diha mo sulod, actually mo connect basically ang topic nilang sa kanilang group sa akong topic next meeting, which is interfacing. And isa sa na-touch ganina, pero okay lang yapon nga wala na-expound, wala mo ko na-expect na expound po to. Pero na-touch to ganina katong signal conditioning. No, isa sa mga slides na ato. So taas nga focus ang atong i-give next meeting regarding signal conditioning or interfacing. So ang pag-interface sa sensor and sa computing device. So kana. Again, thank you. Congratulations to our presenters this afternoon. If you have any additional questions, pwede naman nyo iputang sa GC, no? Or pwede nyo i-ask ang reporters. But again, we'll ask for your slides soon. Please post them sa e-learn. Okay? So in a few minutes, mo-open na to ang mo-open na ang quiz. So you could open your e-learns and watch out, no? Bantayan na lang kung ma-open na ba siya. Any second na ma-open na to. So ay lang sa mag-exit because I'll have some announcements before we really end at 3. Okay? Ay lang maghawa. Or if ever man mo hawa mo para mag-take og quiz, balik lang gyapon mo. Di lang sa nako ni i-close nga room. Okay? We'll end by 3 p.m. We still have 15 minutes. And 5 minutes man akong gi-intend for each attempt. Okay? Any questions? Sa mechanics sa quiz, no? Dili sa quiz mismo. Sa na to. Tanan
Choices to, sir? Ay, multiple choice, sir?
Multiple choice. Pero, ay na mag-take katong reporters, pwede naman dili mo take. Pwede ka po mag-take. I-try ninyo inyong knowledge kasi. Pero mag-expect ko kung mag-take mga na imong 5 ay kamong tulo, dapat perfect kita kay inyo getting report.
Wala.
No thanks na, sir.
No thanks.
Okay. Sige, okay na kayo. Walay minus if ever man dili gid na sinalip na. So ito mo quiz. Pero dili required. Okay, dili required for the reporter to take the quiz. Okay? Sige.
Based man sa kuan, sir, no? Based man
based
sa PowerPoint, sa slides nila, sir, no? Delete sa ilang notes.
Possible gyapon nga nasa ilang gipang explain Yan na. Basta sa ilang report, natutunan sa ilang report. Okay?
Sige.
Ah.
Dagan mo
So-
gud sila katong notes nila sir ba na sila wala gipang
ilahang script.
oil lang script.
Pero I think naman ito na sa slides. Akong pagkadumdum nato sa slides. Akong gipang butang. Sige, kung
Guys.
exit magani mo, balik lang mo. Ha? Di lang ako na i-close. Sige, see you in a while.
Nag-record pa, sir.
Oo, sige. Ako na i-record na. Thank you.